Okay, children, now we are going to start new question in 2023 May-June paper. The paper is 2023 May-June paper. There we discuss about the 19th question number 19 in 2023 May-June paper. So there is a question regarding the mass spectrum of the phosphorus trichloride PCl3 is shown. This kind of the graph is there. So this thing I explained last week. So now the next thing that we have to discuss is the part 3 of that. Show that the relative peak heights given in the table are consistent with the isotopic ratio of Cl35 to 37 being 3:1. So now look at here, they ask us a question. In that question, they ask this thing. What they ask is that I want to show that Cl35 isotope to Cl37 isotope ratio is 3:1. I want to prove that, right? They ask evidence to prove that in that sample, Cl35 to 37 possibility is 3:1. So how do we show that? Right. It's something like this. If you see the graph, in that, if you see the graph, you can see that uh, there is a peak at 101 and there's a peak at 103 and there's a peak at 105. So in that graph, you notice that at the beginning, there's a peak at 101 and there's a peak at, say there's a peak at 103, right? 103 and there's another peak at 105. There's another peak at 105. So the ratio here is roughly 9:6:1. So now using this hints, the ratio is 9:6:1. Using this hint, I will explain you that the ratio between chlorine 35 to chlorine 37 is 3:1. Okay, so how do we go to this question? It's something like this. Now, I think that the question is clear to you that we want to prove that chlorine 35 is a one isotope, chlorine 37 is another isotope. The ratio between this one to this is 3:1. I want to prove that, right? So now look at here. Then when I concern this PCl3 example, now when I concern PCl3, from this we concern the high-speed electron come and bombarded with that, and then it becomes PCl2 plus E plus one chlorine is separated, and then another E plus E, right? If you remember the theory, this E is that high-speed electron comes. This E is what, children? The high-speed electron comes. And this chlorine atom is removed. And this E is the high-speed electron. And this E is the knocked off electron. That is why it becomes positive. So now this question is regarding PCl2 plus species. The question is regarding the species known as PCl2 plus. The species known as PCl2 plus. So we concern one is phosphorus, chlorine, chlorine plus. The other one phosphorus, chlorine, chlorine plus. Phosphorus, chlorine, chlorine plus. Right? So now when I concern this, right, when I concern this chlorine 35 to 37 isotope ratio is chlorine 35 is a one type, chlorine 37 is another type. Here the ratio is 3 and here it is 1. That means when I find 4 chlorine atoms, out of that 4 chlorine atoms, 3 of them, right, out of 4 chlorine atoms, 3 of them coming under this category. That means Cl35 category. When I find 4 chlorine atoms, one of that coming under Cl37 category. Right. So then the probability of finding Cl35 isotope is the probability of finding Cl35 isotope is 3 over 4. Probability of finding Cl37 isotope is 1 over 4. Now, just imagine this chlorine is 35 chlorine and this chlorine also 35 chlorine. You know the phosphorus is 31. So it is, now children, it is 31 plus 35 plus 35. So it is how much? 101. So here, this is regarding 101. There's a peak at 101 in the graph. Right. Okay. Now, what is the probability of being this? Right. The probability of making this is something like this. Now, Cl35 and phosphorus 31. So, what is the probability of finding Cl35? The probability of finding Cl35 is, the probability of finding Cl35 is 3 over 4. What is the probability of finding Cl35? The probability of finding Cl35 is 3 over 4. Right. And what is the probability of finding this chlorine 35? That is also 3 over 4. So what the total is? 9 over 60. Right. Then I go to this one. Now, the second peak is given 103. How the 103 comes? That is because one of the chlorine is 35, the other chlorine is 37. See that this one is 35, the phosphorus is anyway 31, and the other chlorine is 37. So it is 103. The total is 103. So this is what the species, or this is what the ion responsible for the peak given at 103. Okay. Then what is the probability of finding Cl35? That is 3 over 4. What is the probability of finding Cl37? That is, children, 1 over 4. 1 over 4. So what the total is? The next one, 35 and 37. There are two different species. When two different species come, so when there are two different species come, the probability doubles. For an example, say it's an example like this one. Say that blue pen and blue pen. The blue combination only can make. Just imagine the different color pen comes. The red color pen comes. So now what happens? This and this combine, blue-red combination. Again, this and this combine, blue-red combination. When only one type of atoms there, the probability is not double. When the different one is come, what happens? Red, blue, that making the red-blue combination is 2 times than that of blue-blue combination. Now you can understand when the two different species are there, probability doubles, right? In a girl's school, only girl combinations are there. If a boy comes to that, then a one boy can make 3,000 combination with the 3,000 girls. So then there are different number of combinations. Probability doubles when the probability increases when the different species are there. Therefore, now if you carefully look at these, 35 chlorine, 37 chlorine, two different types there. As there are two different types, Now I have to multiply this by 2 because if 35 connect with 37, it makes totally 103. Or the other way around, 37 connected with 35, that also make 103. So it is 3 into 1, 3 into 2, 6, 4 into 4, 16. All right. The next one. Here it is Cl and here it is Cl. Imagine this is 37 chlorine. And you imagine this also 37 chlorine. So this time, first one is 37. You can't see that. 37. And the next one, phosphorus in the middle is 31 and 37. So the answer is 105. So here, this time, this is the ion responsible for the P given at 105. Right. Then, now what is the probability of finding Cl37? Finding the probability of Cl37 is 1 over 4. And this Cl37 also 1 over 4. Right? So it is same type, 37, 37, no need to multiply. So it is 1 over 16, right? Now you see that 9 over 16, 6 over 16, 1 over 16. What are those? 9 over 16 there, 6 over 16 there, 1 over 16 there. 16, 16, 16 is a common denominator. 9 is to 6 is to 1 ratio is there. Right. Now see that if this graph is noticed, if you will notice this graph, here the three peaks are in 9 is to 6 is to 1 ratio. Why that 9 is to 6 is to 1 ratio is there? What is the reason to give the 9 is to 1 is to 6 ratio? Because the probabilities of finding are 3 over 4 and 1 over 4. It is 3 over 4 and 1 over 4. Why it comes 3 over 4 and 1 over 4? That is because their relative abundances are 3 is to 1, right? That is because their relative abundances are 3 is to 1. So, if their relative abundancy were 1 over 5 and 2 over 5, so the answer is 25 over 2, like that kind of ratios come. Why there are 9 over 16? These three ratios came. That three ratios came because the real abundances of Cl35 and 37 are 3 is to 1. That is the reason. So now in my answer, I will write this thing, right? I write all these things in the answer, and I will say that, why this 9 is to 6 is to 1 comes. That is because Cl35 and 37 are really available in 3 is to 1 ratio. That is the answer is. Right. I guess that the answer is somewhat clear to you. Then I go to my next part of the question. So what is the next part of the question is, right, the second D1 part. Draw a dot and cross diagram of PCl3 molecule. Show outer electrons only. That's very easy one. Draw a dot and cross diagram of PCl3 molecule. Show outer electrons only. We will see that how to do that. How do we answer to that question? Let me explain that. It's like this. Now I want to draw the PCl3. Phosphorus is the bit. What I'm going to draw is PCl3. Phosphorus is the middle atom. Phosphorus has 5 outer electrons. 1, 2, 3, 4, and 5. Right? The chlorine is the surrounding atom. So this is chlorine here, and chlorine here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this chlorine has now 8. This chlorine has 8. And this chlorine has 8. and see the phosphorus 2, 4, 6, 8 is there. So that's how the PCl3 diagram is. That's an easy question. I guess you can understand it. Right. I go next one. Explain the shape of PCl3 molecule. The next part they ask is explain the shape of PCl3 molecule. Now we'll see how the PCl3 molecule shape is concerned. Now imagine the center atom is my hand. My hand is the phosphorus. There's a one chlorine here, right? The one chlorine here. There's another chlorine here, right? This is another chlorine. And there's another chlorine here, like this way. It will be trigonal plane, like this. But the thing is, really it is not trigonal planar. Why? Why? That is because there's a long pair here, right? There's a long pair here, right? This long pair repel the bond pair, so it comes like this. This long pair repel the bond pair, so it bends like this. This long pair repel the bond pair, so it bends like this. Now it makes which shape? The long pair repel the bond pair, long pair repel the bond pair, long pair repel the bond pair. So it makes trigonal base pyramid, right? So it makes what? Trigonal base pyramid, right? That's how the shape is made. So what is the shape of this molecule now? Very simple. The shape of the molecule is trigonal base pyramid. The shape of the molecule is trigonal base pyramid. But how do we write the answer to earn the 3 marks? If you carefully notice, there are 3 marks allocated for that. Right. Right. 1 mark is given when you say the shape is trigonal base pyramid. Don't say trigonal pyramid. You better to say trigonal base pyramid or trigonal uh, base pyramid, right? The next one, next point that you want to say that there are 3 bond pairs. See, 1, 2, 3. 3 bond pairs and 1 lone pair is available. In the middle atom, 1, 2, 3 bond pairs and 1 lone pair is available. So you say that 3 bond pairs and 1 lone pair is available. That's the second point, right? Therefore, to minimize the repulsive force, that's the next point. Minimize repulsive force. That is why trigonal base pyramid shape comes, right? The third point is what? To minimize the repulsive force, right? So, and you better to say that this lone pair repulsion anyway there, the lone pair repulsion anyway there, but the bond pair this bond pair repulsions are anyway there, but this long pair bond pair repulsion is strong. Long pair bond pair repulsion is strong. The long pair bond pair repulsion is strong. The bond pair repulsion not that much strong. Long pair bond pair repulsion is strong. That's why it's bent. Bond pair repulsion is not that much strong. Understand that? Now I guess you can understand how the shape of the molecules come. With that, the 19 questions finished, and then I will stop the video. Then we'll come to the 20th question by the new video.